Earth, a planet of our solar system, is really very unique in every sense. It is the place where we live in, where we grow and even die. But have you ever thought about the fact that Earth's uppermost layer on which every means of living is available is not just one landmass? Instead, it is broken into a number of layers technically called plate tectonics. Today we will learn about the upper layer of Earth called the lithosphere. Lithosphere is composed of the hard and rigid outermost crust and the portion of upper mantle. The rigid lithospheric slabs or rigid and solid crustal layers are technically called plates. The whole mechanism of the evolution, nature and motion of plates and resultant reaction is called plate tectonics. The lithosphere is underlain by the asthenosphere, which is the weaker, hotter and deeper part of the upper mantle. Moving over the asthenosphere, lithospheric plates glide slowly over the surface of the globe, much as a pack of ice of the Arctic Ocean drifts under the dragging force of current and winds. On the basis of the movements of plate boundaries, they have been classified prominently into three types: destructive plate boundaries, constructive plate boundaries, and transform boundaries. Now let us have a look at each of these plate boundaries in detail. The first is destructive plate boundaries or consuming plate boundaries or convergent plate boundaries. They are the plate boundaries which move towards each other or two plates converge along a line and the leading edge of one plate overrides the other plate and the overridden plate is subducted or thrust into the mantle and thus part of crust is lost in mantle. At zones of ocean to ocean subduction, the dense oceanic lithospheric plunges beneath the less dense continent. Earthquake traces the path of the downward moving plate as it descends into asthenosphere. A trench forms, and as the subducted plate is heated, it releases volatiles, mostly water from hydrous minerals, into the surrounding mantle. The addition of water lowers the melting point of the mantle materials above the subducting slabs, causing it to melt. The magma that results typically leads to volcanism. At zones of ocean to ocean subduction, older, cooler, denser crust slips beneath less dense crust. This motion causes earthquakes and deep trends to form in an arc shape. The upper mantle of the subducted plate then heats and magma rises to form curving chains of volcanic islands. Deep marine trenches are typically associated with subduction zones and the basins that develop along the active boundaries are often called foreland basins. The next type of plate is divergent plate boundaries or constructive plate boundaries. These are plate boundaries which slide apart from each other. At zones of ocean to ocean drifting, divergent plate boundaries form by seafloor spreading, allowing for the formation of new ocean basin. As the ocean plate splits, the ridge forms at the spreading center, the ocean basin expands, and finally the plate area increases, causing many small volcanoes and shallow earthquakes. At zones of continent to continent drifting, Divergent boundaries may cause new ocean basin to form as the continent splits, spreads, and central rift collapse, and ocean fills the basin. The next type of plate boundary is transform boundaries or conservative boundaries. Transform boundaries occur where two lithospheric plates slide and grind past each other along transform faults where plates are neither created nor destroyed. The relative motion of the two plates is either sinister, that is left side towards the observer, dextral, that is right side towards the observer. Transform faults occur across a spreading center. Strong earthquakes can occur along a fault. The San Andreas Fault in California is an example of a transform boundary. Now, you might have a question in your mind that what causes these plates to move? The answer is the upwelling of magma in mantle. Large scale upwelling and doming of magma produce very huge convection current in the upper mantle, which is transmitted through asthenosphere, resulting into driving of plate tectonics. But this may not be the final answer, as the factors to drive tectonic plates are still under exploration. I hope you enjoyed the video lecture. For more such videos, please let me have your comments on the comment section. Thank you very much for watching.